The general formula for calculating a permutation where you have a total of n objects and you're taking r of them at a time actually involves factorial. So the formula for NPR is actually n factorial over n minus r, quantity factorial. Now, go back to the 6 horses in the race. Instead of asking how many ways all 6 can finish, what if I want to know how many ways the top 4 can finish? So we have a total of 6 horses and we have 4 finishers. So we actually want to know how many permutations are possible if we have a total of 6 objects and we only want to arrange 4 of them. So in that case we would have 6 factorial in the numerator and then 6 minus 4 quantity factorial in the denominator. So that would give me 6 factorial over 2 factorial. 6 factorial is 720. 2 factorial is 2. 720 divided by 2 is 360. Now, do another one. Go ahead and do this one for practice. Show that if you calculate 10p6, you'll get 151,200 for the answer. Now, don't use the calculator on this one. Do it by hand so that you can make sure that you know how to apply this formula. Now, here it kind of shows you how to do the permutation and combination formulas on a calculator, but since I've got you here, I think what I'm going to do is I'll just show you again how you can search for YouTube for the result. So notice what I typed into the search dialog for YouTube, calculating permutations using the TI-84. And so when I type that, I've got several videos here that I can watch that will show me how to calculate not only permutations but also combinations on the calculator. So you can just pick these and see which ones you like, and then use that as a tutorial for calculating permutations and also combinations on the calculator. So when I get to combinations, since I've already covered this, I won't show you how to find this for combinations because it's basically going to be on the same videos as permutations. So here's another one by hand. 7p2 would be 7 factorial over 7 minus 2, and that's going to be 5 factorial. Well, you can use your little shortcut I showed you earlier. Since we know this is going to be 5 factorial in the denominator, we can write 7 factorial as 7 times 6 times 5 factorial, and then of course we can cancel the 5 factorials and just get 7 times 6, which is 42. Now here's an example of where you would want to use a permutation. How many ways can the first 3 places be awarded in a race involving 5 contestants? Now again, we're not using all of the 5 contestants here, so therefore we're going to only use 3, and since the order is going to matter here, it'll be a permutation problem. So 5p3 would be 5 factorial over 2 factorial, which is 5 factorial over 2 factorial is 5 times, if I want to use my cancellation here, I can write this as 5 times 4 times 3 times 2 factorial, and then I can cancel the 2 factorials and just calculate 5 times 4 times 3, which is 60. And then this next one says, how many ways can the positions of president and vice president be assigned from a group of 8 people? Well, the reason that order it matters here is because we're assigning these 2 people to positions. And so when we assign them to positions, see, if I chose 2 people, like let's say I chose Jane and Sarah, well, I could assign Jane president and Sarah vice president, or I could assign Sarah president and Jane vice president. So obviously the order there would matter. So order would matter, and of course repetition wouldn't be allowed there. So I have a total of 8 in my group, so I would start with the number 8, and I want to know how many 2-person arrangements I can make out of 8. So I'm solving for 8p2, which is 8 factorial over 6 factorial, and then I can write the the 8 factorial is 8 times 7 times 6 factorial, so that I can cancel the 6 factorials, and then I get 8 times 7, which is 56. And below here are some more examples that you can look at, and I'll let you do these. You can do these with a calculator or do them by hand, but if you want the number of ways to award the first 3 places in a contest involving 10 people, then that would just be 10p3, which is 720. And this was actually a duplicate of the one above, so I don't know why I wrote it again. And the number of ways 4 people can be arranged in 4 chairs. Well, again, the arrangements are important here, so this would be a permutation problem, and this would be 4p4. And you might remember, since these numbers are the same, that's just going to be 4 factorial, which is 24. Now, here are some special cases. Some special cases of permutations here, and you don't really have to memorize these, but I've already told you that the first one, if you take npn, that's n factorial. But it turns out that if you do npn minus 1, that's n factorial as well. See, so for example, if I said how many ways can 4 people be seated in 4 chairs, that would be 4p4, which is 4 factorial. But if I said how many ways can 3 people be seated in 4 chairs, that would be 4p3, which is also 4 factorial. And then what if you take 1 at a time? Well, if you want to know how many ways you can arrange 1 out of n people, that one's almost silly, but it would be n. So if you said how many ways can we award first place in a race of 10 contestants, that would be 10p1, which is 10. And then this one is even sillier. How many ways can you arrange none of the people? Okay, so the number of ways you can arrange none of the people is just one way. Don't choose anybody. So anyway, again, you don't have to memorize these, but I just thought I'd show them to you. All right, now in the next video, we're going to talk about what happens if the order does not matter. Now go back to the baseball team that we had earlier. I think I said 9 earlier, but anyway, suppose the coach is allowed to nominate 5 players for all conference award. How many groups could he select? Well, first, let's randomly select 5 players like Joe, Sam, Bob, Ray, and Don. Now, when the coach writes the name down, does the order matter? Wouldn't the order Sam, Joe, Don, Ray, Bob be the same as the first group? It would. It would be the same. So, in this example, we would only be concerned with how many subsets, how many 5-player subsets are possible, and we wouldn't care about all the different arrangements within each subset. So in that case, we would be looking for the number of combinations that we could choose rather than the number of permutations. And we'll see that in the next video.